Our planet's oceans have always inspired awe and fear, with tales of monstrous waves dismissed as legend, until now. High above Earth, a satellite captured hard evidence, a single 20-meter wave, as tall as a 6-story building, rising from the open North Atlantic. This wasn't a tsunami or a storm surge, but a rogue wave, an oceanic anomaly science is only beginning to understand. The discovery came not as a dramatic image, but as a sudden spike in a stream of satellite data. For a brief moment, the sea surface surged to an incredible height, confirming that these so-called freak waves are real. The satellite's measurement transformed rogue waves from sailors' tales into scientific fact. Now we can study their origins and frequency with new confidence. This single data point is a key to unlocking the violent, complex dynamics of our planet's blue heart. It's a testament to human ingenuity. By placing technology in orbit, we've extended our senses to the remotest corners of the Earth. We can now witness events that would otherwise go unseen, measuring forces once unimaginable. The discovery of this wave is a reminder that even today, our world holds wonders and dangers we're only beginning to appreciate. The ocean's mysteries are far from solved, and the story of this wave is just the beginning. So, what is a rogue wave? Simply put, it's a wave that towers over its neighbors, more than twice the height of the surrounding sea. Imagine average waves at 3 meters. A rogue wave here would suddenly rise above 6. The 20-meter wave was found where the average was just 8 meters. A true giant. Rogue waves are unpredictable, appearing out of nowhere, often traveling against the wind and waves. They strike with steep, nearly vertical faces, then vanish, leaving destruction and disbelief. For years, science dismissed them as impossible, until the infamous Dropner wave in 1995 proved otherwise. These waves are fleeting, making them hard to study and even harder to predict. They're a stark reminder that the ocean is not a predictable system, but a chaotic, dynamic force. Rogue waves are the extreme outliers, nature's way of defying our expectations. Thanks to satellites, we now have the evidence to study these oceanic monsters. The puzzle is far from complete, but each discovery brings us closer to understanding the ocean's wildest extremes. Detecting a rogue wave from space is a triumph of technology. Satellites like Sentinel-6 and Jason-3 use radar altimeters, not cameras, to measure sea surface height. They send microwave pulses to the ocean and time their return, calculating the height to within centimeters. Thousands of measurements per second create a detailed profile of the ocean below. Corrections for water vapor, the ionosphere, and gravity ensure accuracy. Satellites scan narrow strips of ocean, mapping nearly the entire globe every 10 days. This data reveals not just average wave heights but the rare giants that pass beneath. It was during one of these passes that the 20-meter rogue wave was recorded. Space-based monitoring has revolutionized our understanding of the ocean's most extreme events. The 20-meter wave's discovery was only the first step. Confirmation was crucial. The Sentinel-6 satellite's reading was matched by a nearby scientific buoy, anchored in the same turbulent waters. The buoy's instruments recorded the same extreme conditions, providing ground truth validation. This agreement proved the satellite's accuracy, even for such a rare event. The synergy between satellites and buoys creates a robust, trustworthy dataset. Together, they reveal the ocean's secrets with unprecedented clarity. The 20-meter wave was no illusion, it was a confirmed reality. This event highlights the power of a global ocean observing system. It's a triumph of science, technology, and international collaboration. Rogue waves are born from a perfect storm of wave mechanics. Linear theory, waves simply adding up, can't explain their extreme size or steepness. Modern science points to non-linear focusing. Waves interact, transferring energy to a single, growing crest. This process can rapidly create a monster wave from a chaotic sea. Strong ocean currents opposing wave direction, like the Agulhas current, act as a lens, squeezing waves taller. Underwater ridges and seamounts can also focus wave energy, amplifying their power. When these factors combine, currents, nonlinear energy transfer, and seabed topography, a rogue wave can explode into existence. It's a rare confluence, but when it happens, the results are spectacular and dangerous. The ocean's chaos can suddenly focus into a single towering wall of water. Understanding these mechanisms is key to predicting where rogue waves might strike. But the ocean still holds many secrets. The destructive power of a 20-meter rogue wave is staggering. Millions of tons of water crash down with a force that can bend steel and shatter windows. The hammer blow effect can rip equipment from decks and cause catastrophic structural failure. Ships can be caught in deep troughs, their hulls sagging dangerously between crests. Rogue waves are steep, with nearly vertical faces, concentrating energy into a violent, explosive impact. The downward force as they break is like a wall of water falling from the sky. Survivors describe the experience as surreal, a mountain of water rising from nowhere, the roar deafening. The psychological impact is profound, leaving crews shaken and in awe of the ocean's power. For all our technology, rogue waves remind us that the sea remains untamable. They are the ultimate test for ships and sailors alike. Each encounter is a brutal lesson in humility. The ocean's fury is real, and it demands respect. And yet we continue to venture out, drawn by the challenge and the mystery. Rogue waves are suspected in the sudden loss of many ships, like the MS München, which vanished without a trace. These waves threaten not just cargo ships, but tankers, cruise liners, and even coastal communities. Coastal rogue waves, though rarer, can cause devastating damage to infrastructure and sweep people from shore. Satellite monitoring is now a vital safety tool. While we can't predict the exact moment a rogue wave will strike, we can identify danger zones where conditions are ripe. Real-time satellite data feeds forecasting models, alerting mariners to high-risk areas. Ships can adjust course or speed to avoid these zones, saving lives and property. This early warning system is a direct benefit of space-based science. It's a powerful example of research translating into real-world safety. How will climate change affect rogue waves? The answer is unsettling. As the planet warms, storms intensify, winds strengthen, and average wave heights rise. Bigger average waves mean even larger rogue waves can form. The threshold for a rogue wave rises with the baseline sea state, pushing the ceiling for wave size ever higher. In the Arctic, melting sea ice exposes new waters to wind, generating larger waves in regions once protected. This has major implications for new shipping routes and vulnerable coastal communities. Scientists are racing to model how extreme waves will evolve in a changing climate. Satellite data is crucial, providing the long-term record needed to track trends and validate predictions. The ocean is growing more energetic and more unpredictable. Understanding these changes is vital for our future safety. The 20-meter rogue wave is a symbol of why satellite oceanography matters. These missions are our planet's sentinels, constantly monitoring sea level, currents, and extreme events. Their data underpins everything from flood warnings to safer shipping and sustainable fisheries. The ability to see the ocean globally in near real time has revolutionized our relationship with it. As technology advances, future satellites will offer even greater detail and insight. But with knowledge comes responsibility. The data shows a planet in rapid change. Our sentinels in space are both witnesses and warning bells. The story of the rogue wave connects folklore, science, and our shared future. By understanding the ocean's power, we're better equipped